System modeling, how to validate and verify complex models. Imagine building a detailed map of a city. You want to make sure the map shows the right streets and landmarks. That's similar to what engineers do with complex system models. They need to check if the model is correct and if it reflects real-world behavior. But how do they do that? Let's walk through the process. First, verification is like proofreading your map. It checks if the computer code or mathematical equations are correct. Engineers run tests using problems with known solutions. If the model solves these problems accurately, it means the code is working right. They look for errors like wrong calculations or coding mistakes. This step makes sure the model is solving the equations properly. Next comes validation. This step is about comparing the model's predictions to real-world data. Engineers gather experimental results or measurements from actual systems. Then they see if the model's output matches what actually happens. For example, if they're modeling a mechanical arm, they compare the model's movement with real tests. Validation can happen gradually, starting from simple parts and building up to the entire system. This way, they find and fix errors early on. Uncertainty quantification is also important. It's like testing how changes in weather affect a forecast. Engineers check how small variations in inputs or parameters affect the model's results. This helps them understand how reliable the predictions are. If small changes cause big differences, they know the model needs adjustment. In practice, this process saves time and money. Instead of building many physical prototypes, engineers relying on validated models. They use standards and guidelines from industry to make sure their models are trustworthy. High-quality data from experiments is essential for validation. It's like having accurate reference points for your map. To sum up, verifying confirms the model is solving the right equations correctly. Validating makes sure the model's results match real-world behavior. Using a step-by-step approach from simple tests to full systems helps catch errors early. Quantifying uncertainties shows how dependable the model is. Following these steps helps engineers create models they can trust, which speeds up design and reduces costs. This careful process is key in advanced system modeling and control, making sure the models truly representing the physical systems they aim to simulate.